Thank you. So the concept behind this idea came from the need to try and put things into context for very young children to help them to understand the science going behind it. So we put together the idea of using a story to try and link a series of science demonstrations to help small children understand not only what's going on, but also to give them some context in which to base the demonstrations. So we put together the show. It was aimed really at children between 8 to 12 years. It formed part of the UEA Children's Christmas Lecture last year. And what we want you to do as we go through the show is not just to sit there and watch, but also to think, well, how could I change this? How could I adapt the ideas here to make it relevant to the children, the age of the children in my class, the topic we're studying, and the interests of the children? Okay, so our story starts in around about November, and in the UK, in this time, children get very hyped up about Christmas. There are advertisements, shop fronts, toys galore, and children are constantly spending their time saying, I'd like that for Christmas, I'd like that for Christmas. And the parents' response is usually, well, write it down in a letter to Santa. Now in the UK, it's quite traditional that once children have written a letter to Santa, that they send it up the chimney. There's a fire burning in the fireplace, the letter goes into the fireplace, and up the chimney it goes. And apparently, it gets to Santa. But my question is, why doesn't the letter burn as it goes up the chimney to Santa? How can we stop that letter burning? The answer is in a secret that only parents know, or I hope they do, otherwise the letter will burn. Stephen is going to tell us just what that secret is.
Well, Maxine has a letter for me, I believe. I hope. Thank you very much. So this has been written before. Oh, you want one of those this year, do you? So I have a liquid here, a special liquid that I'm going to use, and we'll see what happens when I work before the show. Well, when I set that piece of paper alight, we'll see that it burns and the letter is would still be legible because there is actually no charring at all on that paper. Now, what's the secret of the liquid? It's a 50-50 mixture of alcohol, which is burning, and water. And the beauty of that is that water, in evaporating, keeps the temperature of the paper low, and it doesn't reach the ignition point, the ignition temperature of paper. We might know the ignition temperature of paper, at least in Fahrenheit, because it's the title of a famous book, Fahrenheit 451.
So Santa is collecting these letters from the children, but him and his elves are already hard at work making the presents, wrapping the presents and storing the presents. Now, it's always eluded scientists as to just whereabouts this happens. But the suggestion is that if all of these toys are being made, there must be huge amounts of raw materials being delivered to the North Pole. And in England, I'm not sure about other European countries, it's very common that when goods are delivered by our larger delivery companies such as Amazon, we get huge packages. We open up the package and inside there is lots and lots of polystyrene packaging, and eventually we pull out the tiny memory stick or something that we ordered. Now, if that's the case, Santa and his team of elves must be working with a huge amount of polystyrene packaging. Just what do they do with all of this packaging? Now, as scientists, we can build hypotheses, and one hypothesis is that actually the North Pole itself is not covered in snow and ice at all. It's covered in huge amounts of polystyrene that Santa gets from his raw materials. Now, as scientists, we want to test the hypotheses. And if that is the case, we expect that year on year, the size of the North Pole is getting bigger and bigger and bigger. But actually, we've done those tests, and what we know is that it's getting smaller and smaller and smaller. So Santa must be doing something else with his polystyrene packaging. Stephen, what do we think he might be doing with it?
Well, I have some polystyrene packaging here, and I have another wonderful liquid here. This is acetone. I was kindly given acetone by the chemistry department here. Now, normally I would buy this in the builder's warehouse, and I know that acetone is an ingredient in nail polish remover. So I can only assume that this acetone is what builders use to remove their nail polish. If we take our acetone and our polystyrene, we can see that Santa may have a way of getting rid of it by dissolving it.
Now, you may find this hard to believe, but a team of scientists and economists have actually estimated that Santa would need a warehouse the size of 240,000 double-decker buses in order to store the presents for all the children across the world. Now, if that's how he stores the presents, the question then starts as to how does he fit those presents into his sack? We feel that this is one of the reasons why he lives at the North Pole. The fact the North Pole is so cold, maybe we start to think about liquid nitrogen and the idea that if you put things into liquid nitrogen, they would shrink. Now, that brings a problem that actually by putting things into liquid nitrogen, it makes them very brittle. And so, the next thing Santa has to think about, once he's got them all in his sack, is how to protect them. And if you come to our stand that we've got, we'll help you to try and think of one of the things we've got as to how Santa might protect the presents that he uses. We'll also help you understand how Santa might remain invisible. In fact, on our stand, we've actually got Santa's sleigh, and indeed, we have made it invisible. So come along and have a look, and we'll show you. We'll also try and help you answer the question, why is it that Santa is so fat? He spent his whole time going up and down chimneys. Surely it would be better if Santa was much slimmer. But no, Santa is always depicted as a very fat and jolly fellow. So why is it that he's so fat? Well, we'll try and help you answer some of those questions on our stand. But what we're moving on to now is to think, how does Santa get down that chimney? The fact he's a very large fellow, he can't just slide down easily. So I'm going to hand you over to Stephen, who's going to try and answer this question for us.
Well, once upon a time, we would heat our houses by roaring fires. Some of us may still heat our houses that way. We'd have a roaring fire, and then we'd put it out at night, and the idea is that Santa will be able to come down the chimney in some magical fashion. But of course, these days, we no longer tend to have roaring fires, but nevertheless, we may find that our house cools during the night. And I've just made my living room here very, very warm by putting some warm water in it. And I have a model Santa here. And with luck, as my room cools, you'll find that being a fat Santa has a distinct advantage because it plugs the chimney, and as the room cools beneath him. Now, occasionally, my model Santa doesn't make it to the living room in one piece. But it's cooling nicely, and he's going in there slowly. Have to talk amongst yourselves for a moment or two. You could also try this by burning something in a conical flask. That would represent the old-fashioned way. There we go. I don't think he's going to make it in one piece today. Unfortunately,